All right, first let's take a look at a few facts about the standard deviation of the residuals. Number one, the standard deviation is the average distance of the actual values from the mean. So in this case, the standard deviation of the residuals is the average distance of the observed or the actual values from the ones predicted by the least squares regression line. The standard deviation of the residuals is what I just said. It's the average distance from the actual values to the expected ones. The units of the standard deviation are going to be the units of the response variable, which is basically the same thing as the units of your y. And the reason for that is whenever you're doing your residuals, remember if this is your predicted and this is your observed, the residuals is your vertical distance. And since it's your vertical distance, that's the same thing as your y values. It's basically going to tell us how much scatter there is about the least squares regression line. So is there lots of distances between your residuals and your least squares regression line, or is there not very many? Most likely you will be given this information until in a later chapter. Basically, it's checking to see how far off are our predictions. Are they off by a lot or just by a little bit? Let's take a look at this example. The standard deviation of the residuals for the F-150 question is $5,740.13. How can we interpret this in context? So remember, it's saying the standard deviation of the residuals is the average distance from the mean. So basically, here's your general statement, and then you can just fill this in with any of the information that's given to you for a problem. So when we use the least squares regression line to predict, then you're going to fill in your response variable to predict the cost using the explanatory variable miles. Our predictions will be off by, and then state how much. So here's what that's going to look like for this example. When we use the least squares regression line to predict the price of an F-140 using the amount of miles on the truck, our predictions are going to be off by $5,740. How much are your predictions off of your predicted value? Now, let's take a look at what R-squared is. This is going to be called the coefficient of determination, and it's very important for your least squares regression equation. The standard deviation of the residuals gives us an average estimate of how far our prediction errors are going to be. There's another numerical quantity that's going to tell how well the least squares regression line predicts the response variable y. Now that is going to be called your coefficient of determination, or your R-squared. And you're going to get this from your correlation coefficient of R. So to get R-squared, you literally just square that number that you get from your graphing calculator. What does it mean? It is the fraction of the variation in the values of y that's accounted for by the least squares regression line. So basically that just tells us what percent of your predictions are accounted for, or what fraction of the variation, what percentage of the variations in the y value are accounted for by the least squares regression line. So here's a formula that we use to get R-squared. You don't need to know it. You can get your R value from your graphing calculator and square it to get your R squares. Now, so that means R squared is always going to be between -1 and 1 also. The R square is going to tell us how much better the least squares regression line does at predicting the values of y rather than simply guessing the average of y for each data set. So basically, if R is 1 and R squared is 1, then that means that the line explains 100% of the variation in y. If R squared is equal to 0.49, then that says that the regression line only explains half of the variation. So that's obviously not going, only half of the variation being explained is not as good as 100% of the variation being explained. So let's just take a look at how we can interpret the coefficient of determination for the F-150 question. The coefficient of determination, or R squared, for the Ford F-150 question is 0.664248. Interpret this in context. Now, I would always change this to a percentage, so this is going to be about 66.42%. So that's going to tell us that 66% of the variation in the price of the truck, so notice that that's going to be my response variable, is accounted for. Now, how is it accounted for? It's specifically accounted for by the linear model that relates the price of the truck and the number of miles given or driven. So here's your general statement that you can use anytime that you're interpreting R squared. So R squared, so that percent of the variation in the Y value is accounted for specifically by the linear model that relates X and Y. Now you can't just say that the percentage of variation in Y is accounted for by X, because it's not accounted for specifically by X. It's accounted for by the least squares regression line that relates X and Y. You can always get your R squared from your graphing calculator. Just make sure you go to second 0, scroll down until you have your diagnostics on, hit enter twice, and then once you go to stat calc and do your lin reg, the R and R squared will be there, so you don't ever have to work for it. Notice right here. Yay! Okay, so let's take a look at the standard deviation of the residuals in R squared. Note that the standard deviation of the residuals in R squared, they do not tell if a linear model is appropriate. We still have to graph. You have to graph them. Once you've decided that a linear model is appropriate, so that is a graph of your scatter plot, okay, and that's showing that the lines follow a linear and not a curved trend. And then a graph of the residuals. Remember, your residuals need to be randomly scattered above the line y equals 0 with no pattern. Then I can use the values of S, or my standard deviation of the residuals, and R squared to tell us how good the predictions will be. So in order to use S and R squared, you must plot the data on a scatter plot and say, hey, is it linear or nonlinear? If it's linear, yay, we're good to go. But you still need to check the residuals. Plot the residuals, and you need to ask the random pattern. If it's random, yes, it's linear. Make sure that you state, since there's no obvious pattern in the residuals, we know a linear model is appropriate. Then you can go ahead and get the least squares regression line and use R squared and your standard deviation of your residuals to answer your questions. Please, please, please make sure you understand that you have to decide if it's linear before you're proceeding. So if it's not linear, none of our predictions are going to be correct or make sense. Now, what exactly is the standard deviation of the residuals? Remember, the standard deviation is on average how far the data points are from the mean. If we're looking at residuals, residuals are how far the observed data values are from the predicted values. The standard deviation of the residuals tells us how far on average the collected values are from the predicted values. We already went over this, but this is just an example. So basically, how far on average are all of these gray dots away from the green line? So what is the average vertical distance of each of my gray dots? Let's take a look at an example that compares the residual plots S and R squared. So in section 10.1, we looked at the relationship between the average number of points scored per game and the average number of wins for 12 college football teams in the Southeastern Conference. A scatter plot with a least squares regression line and a residual plot is shown below. So here's our scatter plot. Notice how we have y squared, okay? Here is our S, that means standard deviation of the residuals is 1.24, and R squared is 0.88. Notice when we graphed it, our dots followed a linear trend, and my residuals were randomly scattered above and below the line y equals 0. So we know that we can use the least squares regression line, S and R squared. Now, let's calculate and interpret the residual for South Carolina, which scored 30.1 points per game and had 11 wins. Now, notice this is going to be your observed value. So we need, and remember, to find your residual. Residual is going to be your observed minus your predicted. Okay, and it's going to be your observed y value minus your predicted y value. So we need to find 11 wins is my observed y. This is my x value. So I know that I have 11 minus, but I don't know what my predicted wins are for 30.1. So we need to find the y hat for this particular value. Now, how can we do that? You have your least squares regression line. If this is the x value that I know, I'm just going to plug that in for x, and I get a 9.4 for the predicted number of wins if they score 30.1 points per game. So to get your residual, you're just going to plug in your information, observed minus predicted, tells me my residual is 1.6. Just as a refresher, since that's positive, okay, remember 1.6 is going to be up here. Positive means your point is above the line. South Carolina, okay, so this is your 1.6. How would we interpret that? South Carolina won 1.6 more games than expected based on the number of points they scored. So here's what they should have won. Here's how many games they should have won. Here's how many games they actually won. So they won 1.6 more than they thought they should. Now, is a linear model appropriate for this data? So you need to make sure that you show two things. One, the graph, and two, the residual plot. Since there's no obvious pattern in the residual plot, the linear model is appropriate, and we already said that it looks like the scatter plot forms a line. Let's interpret the S. Now the S is your standard deviation of the residuals. What does that mean? So remember, that's on average, okay? How far away is the observed value, this is your observed value, from your predicted value? And now notice what's our units here. So remember, our vertical units are going to be the number of wins. Okay, so on average, when using the least squares regression line, X was our points per game. To predict the Y, we are typically off by about 1.24 wins. You don't have to include the rest of it, so you could just say we are usually off by 1.24 wins. Okay, so on average, we're off by 1.24, and it could be 1.24 more wins or less wins. Now notice how we have units here because your residuals are the same as your response variable because they're measuring the vertical distance. Let's interpret the R-squared value, or 0.88. So remember, that is going to tell us how much variation in the response variable is accounted for by the linear model. That's important. So 88% of the variation in wins, notice that's my response variable, is accounted for by the linear model that relates wins to points per game. So that's, once again, we have our response variable here and our explanatory variable here. Okay, so that's actually really good, 88% of the variation. Now, the next thing that we're going to take a look at is interpreting a computer regression output. You're going to be given, in a lot of these questions, you're going to be given what is called a minitab output. They are going to give you basically all the information that you need in this section and in section 10.3. So let's just take a look at what they give you. They give you the slope, and you're going to want to make sure you know how to find that, the y-intercept, and the values of S and R squared. So let's just take a look here. Now, number one, this is what it's going to look like. These things aren't going to be highlighted. This is just your top line that tells you all of your information, okay? This top line, notice how it says constant. So if you think about your equation, y equals mx plus b, what's constant? That's always your y. Y is always the constant. It's just a number. So the top is going to always represent your y. So when this says coefficient right here, think about what is y? Well, that's my y-intercept. How about this right here? Since this is y, your bottom one is always going to be x. And notice how it says miles driven. That's going to be your explanatory variable defined. And since this is your x row, this coefficient, or this, is your slope because your slope is in front of x, okay? Now, this is your standard deviation of your coefficient. You don't need to worry about the values over here for right now, okay? You don't need to worry about R-square adjusted. You can go ahead and cross that off. Notice how this gives you your R-squared value. It doesn't give you your R value. So you would need to take the square root of 0.664 in order to get your R value. And this S over here is the standard deviation of the residuals. On average, how far away is our observed value from our predicted value?